Hey guys, this is Carrie, and this is the answer key video to homework number 6. So we want to completely factor this. So we've got our factoring methods to choose from. Number 1 is GCF. We check it. They don't have any numbers or variables in common, so GCF is out. Number 2 is difference of squares. Oh no, actually number 2 is sum and product, keeping the same order that we've been doing in class. So this actually looks a lot like a sum and product problem because we've got that first term all by itself without a coefficient, and we've got these two other terms. So if we're going to use sum and product to factor it, then we should be able to write it as a product of two binomials, where we have something times something to give us x to the fourth. It looks like that will be x squared times x squared. And then the middle term will actually work out being x squared as well because of the distribution here and here, leaving us with an x squared. Now the last thing we need to do is we need to find two numbers that sum to -5 and have a product of 4. So product of 4 would either be 2 and 2 or 4 and 1. And I think 4 and 1 is going to be more useful for us here. Now that we've got 4 and 1, we need to fix the sign so that adds to -5, so it'll be -4 and -1. So you might think that we're done with this problem, but it says to completely factor it. And it turns out that even though difference of squares worked, or sum and product worked, there's a second factoring method that will continue to be able to factor this. So if we check our next factoring method, difference of squares, these each actually, this one is a difference, this one is a difference, and everything here, x squared, 4, x squared, and 1 are all perfect squares. And so we can use difference of squares twice here actually on each one of these. So x times x gives us x squared, minus 2 plus 2 gives us -4. X times x gives us x squared, -1 and +1 gives us -1. And now we've got the whole thing completely factored into 4 factors. Determine the solution set of the equation square root of 5 minus x equals 3 minus x. So to solve these, we want to get rid of the square root, so we square both sides. That gives us 5 minus x equals 3 minus x times itself. 5 minus x equals, and it's important that we write it this way because that reminds us to distribute, getting 9 minus 3x plus x squared. Rearranging the terms and combining like terms gives us x squared minus 6x plus 9. In order to use factoring to solve this, which it kind of has become evident it's going to be a sum and product problem, we have to set it equal to 0 by adding x on both sides and subtracting 5 on both sides. That will give us 0 equals x squared minus 5x plus 4, which is the same one that we factored above actually. So we get 0 equals, except this one actually has x squared instead of x to the fourth. It's going to be x minus 4 times x minus 1. And in order for these to equal 0, that means either this one is 0 or this one is 0. And that will allow us to say x equals 4 or x equals 1. But remember, we have to check these. And so if you do a quick check here, plugging in 4 on both x's, you find that 5 minus 4 is 1, square root of 1 is 1, 3 minus 4 is -1. This one doesn't work. And if you do a quick check here, x equals 1, 5 minus 1 is 4, 3 minus 1 is 2, square root of 4 is 2, so 2 equals 2, and that one does work. All right, completely factor this expression. So we've tried, we have GCF, we have sum and product, we have difference of squares, and we can try all of those here, and none of them work. But because this one has 4 terms, 1, 2, 3, 4, it's actually the classic format for the final, or not the final, but for the last factoring method that we learned in lesson 6, which is factoring by grouping. So the way this method works is you have to split into 2 groups the expression, and then you use GCF here, and you use GCF here. So if you factor out 2x squared from this one, that will leave you with x plus 5. If you factor out the GCF here, 3, that will leave you with x plus 5. And that gives you x plus 5, the factor that they share in common, and they must share one in common if you've done it correctly, times 2x squared plus 3. And we've got factoring by grouping complete. Last problem, what is the solution set to this equation? Well, because this has 4 terms, all equal to 0, I'm thinking this is probably another factoring by grouping problem. So let's try it. If we use GCF here, we get 3x squared times x plus 5. Verify that in your head quickly, don't just take my word for it. And then here we know we want to end up with x plus 5. So we're thinking, what do we have to factor out so we get that identical factor here and here? It looks like negative 8, when you distribute it to each of those, would give you negative 8x and negative 40. This all equals 0. And we get 3x squared minus 8. And then we have to factor out the common factor, x plus 5, and that equals 0. So to solve this equation, it's actually a little bit trickier. Because this all equals 0, we have either this one must be 0, because when you have something times something and you get 0, either this thing or this thing had to be 0 itself. So x plus 5 equals 0 results in x equals negative 5 as one solution. This factor is actually a little harder to solve. We set this one equal to 0 because we had something times 0, and that still would have given us 0. So we add 8 to both sides. That gives us 3x squared equals 8. Divide by 3 on both sides. That gives us x squared equals 8 over 3. And the last step to solve for x here is to square root both sides, and we get a very ugly answer, but it is still an answer. Remember, square root to cancel square gives you two solutions, positive and negative square root of 8 minus 8 over 3. So our three solutions to this problem are x equals negative 5, or square root of 8 over 3, or negative square root of 8 over 3. And it's nice that we get three solutions to this problem because the cube root here, or cube power here, tells us that we expect three solutions.